Mechanism Friedel-Crafts acylation. This mechanism involves the reaction between arene, which is our main structure organic, reacted with the acyl group, which is come from the acyl chloride, the presence of the AlCl3 as our Lewis acid, and the process substitution occur between one of the hydrogen atom and the group of C double bond OCH3, and the final product is HCl. And the step mechanism, this process are same. We have a 3-step, either first step, our target of the type of reaction, the formation of electrophile, and we can call acylium ion. Second step, similar for another mechanism, the formation of arenium ion, and for the last, the formation of target product by the loss of proton. So the first step is involved between your reagent and our Lewis acid. So according to our reagent, we have a halogen atom that consists a lone pair. So this lone pair will attack aluminium, means this aluminium will accept an electron because aluminium have a lone empty orbital, means this chlorine form covalently bond with the aluminium inside the AlCl3. So our intermediate product form as a CH3, C double bond O, covalently bond remains Cl, a new bonding pair with AlCl3, and this chlorine have a 2 lone pair. And when we check the formal charge for chlorine atom, so 7 minus 6 become positive 1, and aluminium 3 valence electron, and it have a 4 bonding pair will become negatively charged. So means this is a complex structure. But at this stage also, we can form intermediate product electrophile, which is acylium ion, which is this chlorine atom. We require electrons. So what happened? The 2 electron between carbon and chlorine occur. So 2 electron will give directly toward to the chlorine. So means the bond cleavage occur, and we can produce our species of electrophile CH3, C double bond O, and C plus, which is a carbocation, plus our side product AlCl4 minus. Remember, the acylium ion have the resonance structure process. So, this resonance can be formed the alternation, which is the electron distribution inside the molecule. So, the resonance of acylium ion is occur. One of a lone pair at the oxygen will form covalently bond between together. And the new resonance structure form is CH3, C, and we have a triple bond with O. And when we check here, the formal charge of oxygen 6 minus 5 positive 1, and carbon here will become 0. So this is we can call a resonance structure of acylium ion. So, for the second step, by using this structure, we redraw again, proceed to the second step, the formation of arenium ion. So, for second step, our target is arenium. So, it must be involved our electrophile species from the step 1 reacted with the aromatic ring. So, what happened for this stage? One of the bonding pair in aromatic ring will attack carbon, means it can form covalently bond. And once the bonding pair between carbon and oxygen will form a lone pair at oxygen. So, the product formed as your intermediate as a arenium ion. And this stage you must be sure the resonance structure also. Okay, so we use a below side for double, so means our product form at this here. So C, we have a CH3 and we have a double bond O. So lone pair remain become 2. So this is become carbocation. So this stage must be show the resonance. So the carbon double bond alternate with the single bond. Choose the double bond closer to C plus. So this is change position location. So the second resonance structure formed here. Okay, we have a C double bond O CH3. So new double, so positive charge occur at this area and this is a remaining double. Continue change position of the multiple bond. So it can form the new resonance structure for the below side here. So this is a new double, new location positive charge, new double. So C double bond O CH 3. So all the three structure we can call arenium ion and you must re-bracket it. So the next stage for the step 3, you must choose the first structure as the next mechanism. Step 3, we need to prepare our target product. So, the arenium ion, the first structure from the resonance, reacted with AlCl4-, our first intermediate product here. Okay, so what happened? The process involved. One of the lone pair here will attack hydrogen, which is it form covalently bond. So the bonding between carbon and hydrogen will stabilize their own carbon and carbon neighboring carbocation. And at the same time, the covalently bond chlorine and aluminium will break. So electron will give to the chlorine. And your final product form. Okay, so we can form aromatic again and we already choose the final product substitution occur and we have side product HCl plus AlCl3.